Alrighty, episode 2 of C, the Latin of programming languages. So in the last episode, I asked you to do a little bit of research and figure out what these .disim folders are for and what the G flag on the GCC compiler option is. So the G flag just allows debugging information to be seen when we compile a program. So this will let us disassemble our program. And the disim folders are basically like a little logging or crash report folder that Mac OS generates with every executable. So if you're on Windows or you're on Linux or BSD or Solaris or any other of the operating systems, you won't get these disim files. But anyway, so in the last episode, I asked you to create a function that prints out hello world plus name. We're actually going to hold off on that because we need to build some more foundational concepts such as that of variables. So a variable in computer programming is just a way we can store data. So we name our variables, and then we have the data inside of our variables. So say we have, like a long, we could have a paragraph in a variable. Rather than retyping that paragraph over and over again, we'll tag that paragraph to a mnemonic, which will be the variable's name. If that sounds too complex, I probably just overthought it when I was explaining it. It's pretty simple. But as you know, C is a statically typed language, so we need to assign our variables a data type. And basically, when we're doing that, it is just telling the compiler, hey, we need to reserve this certain section of memory that is this large. So every data type is ultimately made up of bits. Data types are of all different sizes, so we need to reserve those sizes in memory for our compiler. We'll get into that later. But the most primitive data type in C is the char. And we can create a char like this. So char, letter, and we can do letter equals A. And we can printf, letter is %C, do letter. We can do printf the size of a char is %D, and we can pass size of, and we do char, boom, 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 and don't worry about %LU versus %D. So we have our char. You can think, so a char is just a single letter. And a string in C is actually an array of chars, if that makes sense. So we'll compile our program again. We will run it, /a.out. And you know what? Let me add, I always forget to do this. Bang, bang, compile, and execute. We see letter is A, and the size of a char is 1 byte. So size of returns the size of the data type in bytes. So a byte is 8 bits. And basically what that means is that for every char, there's going to be, 8 memory slots. So be like 1, 0, 1, 0, 1, 0, 1, 0. And each of these 8 slots can be either a 1 or a 0, and these different combinations of these 1s and 0s will make our letter. So congrats, you just went down all the way to the bits. You have a more foundational understanding of computer programming. But what use is creating a char that is only 1 letter long? What we really want to do is use strings, and we want to create a string called name. So we can do this. We can do char name, and then we have to express the length of the string. Now we can assign our string like this. We can do name equals, well, we have to do it like this. Name 0, we can't do this. Normally, in a language like Python or Ruby, we could just do this. And C doesn't allow that. The computer does not understand that. What you have to do is you need to assign the you need to assign each index of the car array one at a time. And that's not going to work either. So we would have to do something like this. We need to do C and, name 1 equals O. And really, that's really tedious, but thank God for us, there is a function called strcpy, which takes which will basically copy characters into a car array. So I think we need to include the string library to use strcpy. Yep, we do. Okay, I got that right. So strcpy, if you hover over it like this, you'll see it takes a destination and a source. So in this case, our destination would be name. What we want to put in it is the word Corey, because that is my name. And we'll do this. We'll do printf %s name. And just for clarity, we'll do before strcpy, and we'll do after strcpy. So before I run this program, I want to just say this. So you might be familiar with the syntax. This is called declaring a variable. So we're just saying that at some point in memory, inside of the memory segmentation, we need a car of 10 slots long. And when we assign a variable, you use the equal operator, and that is most common, in higher level languages like Ruby or Python. But basically, the point I'm trying to get to is that you don't need to assign and initialize a variable all the time. Normally in C, what you'll see at the beginning is a programmer will, they'll figure out like, okay, these are the variables I need, and they'll declare those all at the top of their program before assigning them later in the program. It's just a pretty universal architecture that you see in C programming languages, in the C language. So we'll compile our program once again, and we will run it, and we see, before strcpy we have nothing, and then after strcpy we have our name. So the strcpy function, we just pick a destination, which is our variable or a memory address, and we pick the data that we want to put in it. You could alternatively, rather than using strcpy, you can go like this, and that is fine as well. Make sure these are double quoted strings. You'll see if I turn these to single quoted strings, I'm going to get an error, because the single quoted string, I believe, is just reserved exclusively for single cars, single digit cars. So you can initialize and declare a car at the same time, but strcpy is a lot more common. So now, how do we print out the name? We do printf hello world. My name is %s \n and name. So I actually forgot to explain what this %s syntax is. This is called string interpolation. So depending on the data type that is present, you'll do percent and then an abbreviation for the data type. Again, it has to do with the memory of the program. So %s means string, so you're putting a string there. Also, you need to think, the compiler and the CPU need to know how to interpret the bits, and that is what this syntax is for. So you can almost pretend, the name variable is going into this %s right here, and we can actually, even if we assign, we'll demonstrate something real quick. So let's say that I wanted to add something onto name. I wanted to do my middle initial. So I could do name, and at the Y we are at the 0. So this is string indexing. It's a list, 0, 1, 2, 3, 4. So I want to do 6 just to leave a space. I will do Z. You'll see, copy this, you'll see that we can edit the string in real time, just like other programming languages. Of course, you could stir copy this, but anyway, let us run the program. You'll see, hello world, my name is Corey. Hello. Oh, this actually didn't work. Maybe I could do, maybe if I do this. All right, so I'll leave that for the next video on how to edit strings. But anyway, congrats. You learned about the card data type. You learned about the size of the card data type. You learned how to use the stir copy function. In the next video, we're going to disassemble this program, debug it a little bit, learn how to set breakpoints, learn what registers are, etc. And we're also going to learn how to edit strings after they are assigned. So thank you for watching. Be sure to like and subscribe. I will see you in the next video.